Hey folks, so in this video I am going to walk over this fun little project that I've been working on. I'm calling it Project Cyber Safari, and the idea being that there's a bunch of offense going on, there's a bunch of defense going on. It's kind of a wild world out there, right? And this project basically is a collection of different AI security agents and the use cases as trying to build my understanding of how AI agents and how securing them and building agents for security works. So the idea being that I'm hoping that other folks could also contribute to it with their ideas. We can actually make something out of it. So having said that, what I have right now so far is two agents, one an offensive or a hack agent that I covered in my first blog. You can go to my website and then it's right there. And then the other agent is the defensive agent. And then there are some tools. So the tools are what these agents will use to do certain tasks to achieve a certain objective in a way, right? And the prerequisites is obviously you start a virtual environment, you activate it, you install the requirements file, you export your OpenAI API key. It uses OpenAI API to for all the LLM based calls basically. In terms of the code walkthrough, I already covered the two agents, already covered the tools. The security docs is basically a directory that has certain security best practices. So if you look at the authentication directory, you can see that there are two files, DWT implementation and auth guidelines. These are all hypothetical security best practices generated by ChatGPT. So they might not be super accurate, but for the purpose of this POC, it works. In this particular case, you can see that there's a very weird best practice of including this decorator. This I added intentionally because I wanted to see if the recommendation that the defensive agent comes up with is actually being retrieved from the internal documentation or is it just kind of hallucinating. So that is why I have this particular value here. Similarly, if we go back to authorization, again, there's two markdown files, admin security and RBAC implementation. If you look at the admin security markdown file, similarly, I have a very specific header here, X on my auth, to again see if the defensive agent is able to retrieve this particular recommendation or not. So that's pretty much it. There are two other files, the rack setup.py and the testlab.py. Rack setup.py is something that you have to run initially to set up the vector database. It uses a ChromaDB under the hood. But this is essentially a database that is curated using the security documents that I just walked over. So those are their vector embeddings are stored in this vector DB, and which is what the defensive agent uses to retrieve security best practices. And the testlab.py is the vulnerable app server, which is serving malicious JavaScript file, right? So the architecture of Project Cyber Safari so far, and again I mentioned so far because it is capable of extending into whatever we want it to be. I think the possibilities are endless. But for right now, this is what it has. So there's obviously the application server, the vulnerable app server that is serving a malicious JavaScript file that has three API endpoints with some vulnerabilities on each one of them. And then this application server maintains a log file of all incoming requests to that application. There's an offensive AI agent and then there's a defensive AI agent. The offensive AI agent analyzes the JavaScript file, finds API endpoints, any additional parameters or secrets that are required to send successful requests to those API endpoints. It then carefully crafts those requests to those endpoints, sends it, and then analyzes the response to see if anything was or not. So that's what the offensive AI agent is capable of doing right now. The defensive AI agent reads the log file from the application, then it identifies attack patterns of what is it that might be going on against the application. It then queries the internal knowledge base of security best practices, which is the RAG system here, for security controls that are recommended inside an organization for particular classes of vulnerabilities. And then based on data retrieved, it provides a recommendation to the application user so that they can go and actually fix it. So that's a very high level overview here. Now actually let's walk through the code. So I'm inside the root directory. You can see that the app logs are empty. You can also see that the KB directory is empty, right? So the first thing to do is to create the RAG database or the vector database. So for that, you just run that command, and you can see that it uses ChromaDB under the hood. It processes all the markdown files, and it has created this security best practices knowledge base which can be queried and data could be retrieved from it. Cool. The next thing to do is to start the vulnerable app server. So for that, just start the testlab.py. Cool. So you can see that the server is up and running. If I come to a different screen here, so let's see if I do so now you can see that the app.log was generated, but there's nothing in there for obvious reasons because we haven't sent it any requests. So let's send it some call requests. You can see that I'm sending it to 3 different API endpoints, and each one of them comes back with some response. And if I go back to the app logs file, you can see that the 3 requests are actually showing up in the logs, which means the application is correctly generating the application logs of all incoming requests. Cool. Let's quickly check the security KB directory as well. Okay, so you can see that when we ran the RAG setup file, it created this vector DB and all the contents are inside the security KB directory. All right, cool. So we have the app server that is vulnerable and up and running. We have set up the internal knowledge base of security best practices. Now the first thing we do is run the hack agent. The hack agent starts security analysis. It finds out that the application has 3 API endpoints. It starts to analyze the JavaScript code to find out if there's any specific requirements for these endpoints. So for the first one, it finds out that it uses a custom header user ID. It was able to find this value from the JavaScript file itself. And then it actually sends a call request with that header. You can see that. And it was able to get a response back, which looks like some exposure widget correctly identified here. It then proceeds to the next API endpoint, user info, finds out that there's no authentication required, and it sends a request to that API endpoint and finds out that sure enough there's some exposure here as well. There you go. And then finally it proceeds to the last API endpoint, v1 admin. It finds out that it requires a super secret admin key, and this is the header for that. It generates a test configuration, sends a call request. You can see that the header was here, and then it gets back API gateway and a database credential. So sure enough, again, it finds out that there was sensitive data exposure. So this should complete the hack agent security analysis. So it was able to find the vulnerabilities in all the 3 API endpoints as expected. Awesome. Next thing we do is run the defensive agent. So the defensive agent starts by analyzing the application logs for the attack patterns. So this is the analysis. It found out that the attack type is unauthorized access attempt against these 2 API endpoints, and the indicators are these 3 things. And then this is a vulnerability, and then this evidence comes directly from the log file. This makes sense because these 2 endpoints required specific headers, and if they weren't passed, they would respond access denied error message. So if the defensive agent sees those access denied message and then successful message, then it knows that something was up. So I think it did a pretty good job in identifying that. Yeah, it mentions here. And then it is querying the vector DB, ChromaDB, to find out security controls against this unauthorized access attempt vulnerability class. So here you can see that it was able to retrieve 3 controls, and the 2 that we expected to find are here, right? This particular decorator and this particular header for the proxy. And then I think it also found out something about RBAC implementation. So that's cool. It was able to find 3 relevant security controls from inside the organization's knowledge base of security best practices. And then it tries to generate the security control recommendation. So this is what the prompt looks like. It provides the attack analysis, and then it provides it the 3 security controls that it was able to retrieve from its knowledge base. And then it says generate a specific recommendation, right? So that's what it will do. It comes up with some immediate actions, and you can see that the XYZ JWT required a decorator is mentioned here. The X on Y hot is also mentioned. So the defense agent is doing what it's supposed to be doing. Yeah, I think that's pretty much it.